The two main information in the carbon NMR is number of signal and the chemical shift. Okay, so we have gone over both informations. Now we have to apply. All right. So to help you be more familiar with all those two information, let's draw together. It doesn't have to be perfect. It doesn't have to be pretty. At least you get an idea what the carbon NMR of a compound looks like. That's all good. Okay. All right. This is what I want you to do. So I'll do this. You can do it by yourself first, or you want to go over this together, and I have next one for you to do. But at least one time, I want you to try on your own. Okay, maybe you can do this one together. All right, let's do. This one, you have to draw a carbon NMR spectrum of this compound, right? So we have a chlorobutane. Okay, and let's see how to draw this. Well, look right. If you look at this molecule right here. A, B, C, and D, which one would be more D-shielded? Which one would be more D-shielded? A, of course, it's closer to the fluorine electronegative atom, right? And B, C, and D are further away, just like inductive effect. So decreases over distance. So B gonna be less positive, C gonna be less positive, and D gonna be even less positive. Okay, so A gonna be the most D-shielded, and D gonna be the most shielded. Okay. All right. Now, where should we draw this the signal of A? If you look back to think about this though. Oxygen, carbon next to the oxygen have the chemical shift of about 60 ppm. Chlorine has higher or lower electronegativity than oxygen. Lower. It's gonna be less than 60. Okay. If you go back to the chart, it's about chlorine about 50, just like that electronegativity trend. All right, so I'm gonna go with about like in the middle of the range. So the carbon A should be about 50 ppm. It could be up somewhere around here. All right, carbon B gonna be more shielded than carbon A, so because further away from chlorine, so gonna be appear upfield on the right side of A. That's B, somewhere right here. I don't know. It's about right here. At least you get the trend. And then C and D. Okay. Now compare this to the real carbon NMR spectrum of chlorobutane. Take a look. Really close. Really close. Right? That's all you have to do. Okay. All right. I'll have you do this on your own. Can you do that? All right. Pause the video. Okay. And when you've done that, let's go with me. All right. I'm gonna draw the line. So, hold on. We got A, B, C, D, E, and F. Okay. For sure, A is a regular carbon, right? So appear on region number 1, gonna be the most shielded one. So gonna be right there. That's A, an alpha carbon, right? B, aldehyde ketone. That's an aldehyde ketone. Okay, if you remember, aldehyde ketone show up above 200 ppm. All right, so right there. However, is this carbonyl carbon, the B, is conjugated with the benzene ring, so they got resonant effect. All right, so move B down upfield a little. I'm gonna move just about it, maybe a little bit low, about 200 or lower, something like that. We're just guessing. Okay, doesn't have to be exact. All right, so that's B. Now we got C, D, E, and F. So we have 4 more signal to go. Okay, C, D, E, and F are sp2 carbon on benzene ring, so that's about 120. So we're gonna go something like right there, 4 signals. All right, and I'm going to put C right here, only because if you remember this trend, quaternary carbon is more D-shielded than the rest. All right, so carbon right here, D, E, and F going to be really close now, so we're going to put them together right there. So I don't know. Okay, all right, look at the real spectrum. There we go. Yeah, close, pretty close. You know that? So you just have to use this chemical shift often. I do not want you to memorize anything except 60. Just a 60, that's all you need. That's your reference point. Okay, the rest you can draw the line out, right? And then you can know region 1, 2, 3, and 4. Aldehyde ketone above 200. The rest of carbonyl compound less than 200, something like that. Okay, region 3, benzene, alkene. Okay, just use this often, right? And it helps. Do not memorize anything except 60 ppm. All right, let's move on to the techniques in carbon NMR. This all this gonna help you interpret the structure of the molecules.